Okay, continuing on our work with quadratics. We've talked about vertex form. Now we're going to add a little bit of standard form and how to interpret those. Also how to identify what quadratics are. So one of the essential questions, how you can change the vertex form of a quadratic function to standard form. Again, it's also identifying information from standard form and that we saw when we did vertex form. So first off, just identifying quadratic functions from their graphs. And then also just from the equation. So as we look at these equation-wise, we'd say that this one is no. This one is no. This one would be yes. This one here is yes. And then yes, and then no. Okay, and I'll talk about specifics of those, but let me add in our graphs so we can look at those as well. Okay, so as we look at these first couple here, we have our x plus 1. Then we have 2 to the x power. And last, we have negative x minus 3 squared and plus 7. So as we look at those three graphs as well, we can see that the red one, the blue one, and the green one are all different. The first two are no, so that red one is a linear equation. The blue one is what we call exponential equation, and the green one is our quadratic. So as we look at our equations, the quadratic is the one that most importantly has an exponent, but also a squared as an exponent, or a 2 as an exponent, because the second one here has an x as an exponent, but that doesn't make it a quadratic. That one is what made it an exponential. All right, so let's look at our other side. All right, so our first one, let me turn these off real quick. So we have x squared plus 2x minus 6. Then we have 2x squared minus 3. And then the square root of x. So as we can see here, our first two, we have yeses on them. We have our exponents that are 2's, and our graph has that parabola shape that we've been talking about. And so those are yes. Our last one there is no exponent of a 2, and it definitely does not have that shape that we're looking for. Okay, so that's why we'd have those as our exponents. As squared, when we're looking at the equation, and then the graph, we're looking for that u, or that parabola. All right, so moving on here. So a couple reflection questions. How can you determine whether a function is quadratic or not? By looking at its graph. How can you tell if a function is a quadratic function? By looking at the equation. So go and write your answers down for those and be ready to respond to those questions in class. All right, so now we're going to move into identifying quadratic functions in standard form. So we've talked about vertex form, which is a quick reminder, was f of x, could be y of x, or just y, not y of x, a x minus h squared plus k. Now standard form, and opposed to that, is f of x or y, I'll write it with a y this time, ax squared plus bx plus c. And then so from there, our axis of symmetry, since we're in a different form, we got to do a little bit of work. We have a formula that's negative b over 2a, where the b comes from there and the a comes from there. So that's how we can find our axis of symmetry, and then once we have that, we can then substitute that value in, and our vertex becomes negative b over 2a, and then that value substituted in becomes your y value. Technically, it's f of negative b over 2a. That's one way to write the y value. All right, so let's look at how to actually apply that now. So number 3 here, we want to find our axis of symmetry, then our vertex. So we have x equals negative b, so that is a negative 12 over 2a, 2 times negative 3. So negative 12 over negative 6, and that equals a positive 2. So we would say our axis of symmetry is x equals 2. And then to find our vertex, we're going to substitute that value in, and we get negative 3, 2 squared, plus 12 times 2 minus 5. Simplifying here, we get negative 3 times 4, plus 24 minus 5. This gives us a negative 12 plus 24 minus 5. That was a 24, not a 25. So then all said and done, we get y equals 7. So then our vertex for this one would be 2, 7. All right, let's look at number 4 here now. So x equals negative b, which in this case is a negative 2, all over 2a, which is 2. 2 negatives make a positive, so that's positive 2. 2 times 2 is 4, so that equals 1/2. So we'd say our axis of symmetry is 1/2. Then we want our vertex, so I'm going to substitute that value in. So 2, the squared goes to the top and bottom, so 1 squared is 1, 2 squared is 4, so we get 1/4. Multiply straight across, and we get negative 2 over 2, and then plus 8. Multiply straight across, and you get 2 over 4, which then we reduce to 1/2. Negative 2 over 2 is just 1, and then we want to add 8. So from there, we're going to simplify, make all these denominators a 2, so we get 1/2. This one becomes a negative 2 over 2. And then this becomes 16 over 2. Go ahead and now add your numerators. So 1 minus 2 is negative 1, plus 16 is 15/2. So we would say our vertex for this one is 1/2 and 15 over 2. All right, so one to think about. Explain why the function represented by the equation y equals ax squared plus bx plus c is a quadratic only when a does not equal 0. So another way to think of that question, and maybe this will help you with your response, is what would happen if a does equal 0? All right, your turn here on number 6 and 7. Determine if those are quadratics or not. Again, be ready to give your reason when you come back into class. All right, one other thing that we have to do is change from vertex form to standard form. This is kind of an introduction. We're not going to hit this too heavy, but want to introduce you to this concept. So given our vertex form, we want to take and put it in that form. So what we're going to do is we're going to take this middle part and we're going to expand it first. So that's the same as x minus 6 times x minus 6. As I multiply that, that gives me x squared minus 6x minus 6x, and then plus 36. Simplify that down, we get x squared minus 12x plus 36. So then we have our 4, and then x squared plus minus 12x plus 36, which I'm going to distribute in. We're going to leave this plus 3 alone. So that gives me 4x squared minus 48x plus 144. And then we have that plus 3 on the end. And then last is to simplify. So we get y equals 4x squared minus 48x plus 147. All right, number 9, so we're going to expand. We get x plus 2 times x plus 2. Distribute, x times x is x squared plus 2x plus 2x plus 4. That gives us x squared plus 4x plus 4. Now we're going to distribute that negative 3 in. So we get negative 3x squared minus 12x minus 12 minus 1. So y equals negative 3x squared minus 12x minus 13. All right, so now we're going to write equations given a table. So we want to identify our vertex. So remember, our vertex is that point there or that point there where we have mirrored points. So what we want to look for as we do this is mirrored points in our table and where that turn happens at, which would be our vertex. So I have 9, 9, 1, and 1. And then so negative 3, 0 would be our vertex. And so then we would be y equals a, x minus our h, which is a negative 3, squared plus k, which is 0 in this case. And so then that simplifies to y equals a x plus 3 squared, and then there's no 0. Now what we want to do is we want to pick any point in our table in order to find our a value. What I'm going to do is I'm going to pick one of the ones just to either side of the vertex. Usually works out for the least amount of numerical value. And so I'm going to go with the negative 2, 1. So 1 is my y value. So I get 1 equals a, and then negative 2 plus 3 squared. Means 1 equals a. Negative 2 plus 3 is 1 squared. And nice thing about picking it just on either side like that, 1 squared is just 1. So we get 1 times, or 1 equals a times 1, which is just a. So then our equation for this would be y equals 1 x plus 3 squared. And that's our answer. All right, let's try number 11 here. So even, And so there's our vertex. So that's at -2, -3. Our vertex form, we got x minus a -2, which is going to give us a +2 squared, and then -3 for a k. Pick any point. I'm going to pick the -1, 1. So it gives me 1 equals a -1 plus 2 squared minus 3. That gives me 1 equals a 1 squared minus 3. So we get 1 equals a minus 3. This time we have to add that 3 over. And we get 4 equals a. Now, if you'd pick something else besides that and you got a different value in here, all that would happen is you'd have a number in front of your a. You'd have to divide by whatever that number is, and then that would give you your a value. But choosing correctly, it saves us a little bit of work. We don't have to do that. So for this one, our equation would be y equals 4x plus 2 squared minus 3. All right, so go and try number 12 there for you. We'll talk about that one in class. And for 12 of those, you want to check your work. It's going to be y equals 6, x minus 2 squared plus 5. All right, write an equation, a quadratic function given a graph. So similar deal. We have a graph. We want to identify our vertex. So in this case, it is at 0, 25. So then our vertex form, y equals a x minus h, which is 0. So that can just go away. And we end up with x squared plus 25. Pick another point. So the point they give us there is 1, 9. So it gives us 9 equals a 1 squared plus 25. So we get 9 equals a plus 25. Subtract 25 over. And we get a equals -16. So our equation would be y equals -16 x squared plus 25. So again, write an equation. Our vertex is at 1, 1. So we have y equals a x minus 1 squared plus 1. Pick another point. The other point that they give us is 3, -3. So we get -3 equals a 3 minus 1 squared plus 1. -3 equals a 2 squared plus 1. We get -3 equals 4a plus 1. Now we're just solving. Subtract that 1. And 4a equals -4. Divide by 4. And a equals -1. All right, reflection questions. What is the standard form of the quadratic function? How many points are needed to write a quadratic function in vertex form given the table of values? And then work on your quizzes. Don't forget that so you can get full credit on your notes. And your homework assignment. All right, so page 247. Numbers 1 through 9, 12 through 20, even, and 24.